everyone, good afternoon. Thank you for joining the Blue Economy CRC webinar series. Today's webinar is about decarbonising the blue economy through accelerated adoption of ocean energy. This webinar will run for a couple hours. Just to introduce who I am, I'm Professor Irene Pennises, Research Director of the Blue Economy CRC. The Blue Economy CRC was established under a 10-year life under the Australian Government CRC program in July 2019. We have 40 participants from Australia and around the globe, and the purpose of the Blue Economy CRC is to perform world-class, collaborative, industry-focused research and training that underpins the growth of the blue economy through increased offshore sustainable aquaculture and renewable energy production. Before I go into a little bit more detail about today's webinar, I'd like to just acknowledge, to begin by acknowledging the traditional custodians of the land in which we meet today, and pay my respects to their elders past and present. I extend that respect to the Aboriginal and Torres Strait Islanders people here today. Today, those in Tasmania are meeting on Lutruwita Aboriginal land, sea and waterways. Today's webinar is definitely on a topic that's very close to my heart, having worked in ocean renewable energy now for about 15 years. This webinar really is going to provide an opportunity to bring attention to an emerging ocean renewable energy sector that promises a highly effective means to decarbonise the blue economy. For those who may not be so familiar with this area of renewable energy, to date, energy from our oceans has been too often overlooked, even with its unique advantages and ability to integrate with other renewables, adding consistency, complementarity energy to the supply and the grid. The Blue Economy CRC's research into the synergies between offshore aquaculture production and the use of renewable energy really will showcase this benefit. I'd like to just start by also saying a few words about the Australian Ocean Energy Group, who today, Stephanie Thornton, who's here as the cluster manager, will help facilitate the webinar today, and the excellent panel that we've put together. The Australian Ocean Energy Group is an industry-led cluster that was formed in 2018 to accelerate the commercialisation of Australia's ocean energy as the next frontier in low carbon generating capacity. AOEG was formed with seed funding from National Energy Resources Australia, so NERA, and partnership with Climate Kick Australia as well. AOEG aims to accelerate the adoption of offshore renewables through its comprehensive ocean energy market development program. This novel approach will catalyse commercialisation of ocean energy by changing the dynamics from technology push to market pull. So I'm going to start by introducing Stephanie Thornton, who I mentioned is the AOEG cluster manager. Stephanie is one of the founders and current cluster managers in AOEG, an industry-led cluster who aims to accelerate commercialisation of our ocean energy sector. Stephanie has over 14 years international experience in this sector, very passionate about generating a market pull for ocean energy, and sees this as a key to successful commercialisation of her sector. She brings a lot of experience from work that she's done in Norway and in the Australian ocean energy technology developers, along with industry development in the US and Australia. So I'm very pleased to have Stephanie working with me today to facilitate this session. We also have a very exciting panel before you today, and I want to introduce those people as well, who are all partners or members of the Australian Ocean Energy Group. So Alex Ogg, thank you very much for joining, also part of AOEG and has a very key role as Ocean Energy Marketplace Program Manager, and you'll hear from Alex a little bit later on in the webinar. Michael Byrne from EHL Australia, who have been developing the Azura wave power technology. Tom Dennis, Executive Chair of Wave Energy, who will, I'm sure, tell us a lot about their project at King Island in Tasmania. Jonathan Faves, CEO of Carnegie Clean Energy. Sam Layton, CEO of Bombora Wave Power. Roy Mitchell, Mechanical Engineer for One Tide. Terry Moen from Australian Microgrid Centre of Excellence. Darren Powell, Managing Director of Smart Barge. And Chris Shearer, Associate Principal Engineer at BMT Commercial. I want to welcome our panel and thank them so much for their time today. I'm actually very fortunate to have had a long working relationship with many of the people and organisations on the panel today through my role prior to the CRC as Marine Renewable Energy Research Lead at the Australian Maritime College at the University of Tasmania. And of course, with the Australian Ocean Energy Group, Carnegie Clean Energy and BMT are all participants of the Blue Economy CRC. So I'll welcome their presentations, and I'm sure they're going to share a lot about what they've been doing with the CRC as well. And of course, the Blue Economy CRC is also a reciprocal member of AOEG. For this panel, we did actually invite several women from membership organisations of AOEG to be on the panel, but they were unavailable. The CRC is strongly committed to gender inclusivity and actively committed to supporting the importance of championing and enabling women. Both Stephanie Thornton and I are committed to working closely together to champion more women in marine renewables, and also to bring awareness and visibility of the marine renewable energy industry and associated industries and supply chains, and through the membership of AOEG today through this webinar. So I'm really looking forward to getting us started today. Some housekeeping for those who are joining our webinar. There are two functions there, the chat and the Q&A. We'd like to make sure that we encourage you to use the Q&A function to ask your questions today during the webinar, and the speakers will answer those questions at the end of their presentations. Attendees are able to upvote questions in the Q&A, so most popular ones get up to the top. If you wish to direct your question to a specific person on the panel, because you'll hear from quite a few different people about them, their projects, their technology, please indicate who that is in your question that you post. And our panel also will try and answer some of the questions whilst the webinar is occurring as well. Please only use the chat function if you're experiencing any technical issues or you have a question to any of the panelists that you don't want posted in the Q&A discussion. The best way to view this webinar is to make sure that your screen is on speaker view. So with that in mind, I'm going to hand it over to Stephanie Thornton. Thank you, Stephanie. Look forward to hearing about this exciting discussion today with these great panel members and helping with an excellent Q&A. Over to you.
That's great. Thank you, Irene. Gosh, I'm really excited to be here today, and especially to thank you and the Blue Economy CRC for inviting AOEG to share a lot of its exciting work that it's doing in ocean energy innovation. So in addition to that, I'm also very excited to get feedback from the audience and to hear your thoughts and respective ideas, and hopefully engage you in a lot of the projects and work that we're doing. It certainly takes a village to accomplish great things, and we look forward to having your participation. Irene did a fabulous job introducing and setting the stage for us, and what I'd like to do is dive in just a little bit deeper to tell you, to share with you exactly what we're thinking about and hoping will be the outcomes for today and what we hope that you will get out of it. First and foremost, that as Irene mentioned, we're talking about decarbonization of the blue economy through the application of ocean energy. And through that, through our discussions today, we hope that it really increases the understanding of the opportunities and challenges that it takes to create market demand for ocean energy. It's one thing to create the technologies, of course, but another thing to have the customers and to find the place to fully deploy them. So we hope to bring some awareness about those challenges. The second thing is that, and most importantly, in which the centerpiece of this webinar is to bring visibility to these exciting innovations through our presenters today. There are some amazing technologies that are being developed, and I hope that you'll find them very, very exciting. And then the third thing is towards the back end of the presentation, my colleague Alex will be speaking about and sharing AOEG's work at an industry level in terms of building market awareness and engaging markets. The program, just as a full general recap, the program is going to be in 4 parts. I'm going to open by talking a little bit about the challenges of market demand, which will lead right into the presentations, and then we will have a first Q&A so that you can speak to and ask questions from our technology developers and our other presenters. And then following that Q&A, Alex will then share the industry. Share the work that we're doing on the industry level, and then we'll open it up for a full Q&A. So we do have an action-packed agenda, and I hope that you'll find it very interesting. So without further ado, I thought it would really be helpful to open this webinar and kick off the program with sharing a short story with you. Recently, I was invited to speak at a sustainability forum and introduce the topic of ocean energy. And I thought, great, my favorite subject, not a problem. I'll talk about all the exciting innovations that our members are doing, and it'd be a piece of cake. Well, little did I know that during the planning process and during the design, the organizers asked me to explain actually personally why I'm involved in ocean energy and what drives my involvement in AOEG. And not only that, then they threw me a curveball and said, you have to show an image that represents that story and your personal connection. So I did that and all went well. So and they encouraged me to share the same with you. So I'm actually going to do that. So what many of you may not know about me is that I actually grew up on a commercial fishing boat. And my family moved on the boat when I was 6 years old, and we literally lived on that boat for the next 10 years. My dad made his living as one of the early commercial abalone divers in Southern California, and we fished tuna during the summertime. So this picture is me showing off a bonito that we caught on the way out, traveling out to the Channel Islands where the commercial abalone diving took place. So the question, I'm sure it's all in your mind, well, what does this story have to do with ocean energy? Well, the connection is that growing up on a boat meant that the ocean was literally my playground. And because of that, I really do have a deep connection to the ocean and its living environment. However, the other side of me, because my family made a living on the ocean, I also understand the economic potential and the value that can come from the ocean. So it's because of ocean energy that, sorry, can you go back to the previous slide? So it's really because of this environment and growing up on the ocean that I understand the connection to what's possible. And it's because ocean energy can really operate in harmony with the environment, and because it can address climate change, that I really believe in and am passionate about ocean energy. So that's why I'm working to help the industry succeed and to grow. Next slide, please. But this does lead me to one of the big questions, which is, with over 70% of our Earth covered by oceans and over 85% of Australia's population living within 50 kilometers of the coast, I wonder why energy from the ocean is really not a mainstream source of renewable energy. It's really one of the biggest challenges that that stumps me and I think about a lot in the work that we do. And to date, we know that energy from our oceans has really been too often overlooked, despite the fact that it really is an energy source with almost limitless potential to produce clean energy more consistently and predictably than any other renewable source. And when we combine that with other renewables, such as into an energy system, such as a microgrid, it can really add huge value as a low-cost renewable energy source. So considering that opportunity, we've realized that this really can provide energy solutions for those coastal and remote communities, businesses, and industries in the blue economy that are seeking to reduce emissions and to undertake an energy transition. Next slide, please. So if ocean energy is that great, then the question is, why isn't it on par with offshore wind in terms of maturity? And what are those barriers? There are many reasons, but one of which is the fundamental difference between offshore wind and ocean energy technologies. First, the offshore wind sector, the offshore wind sector has emerged around a single device design, which is the wind turbine. And I know that many of you are all familiar with that. And there's really hasn't been too much variation in the basic technology design, except for strong increases in efficiencies and cost reductions. And I know that there's many other improvements, but basically the design is the same. And second, offshore wind sector produces gigawatt level utility scale energy production. And that's a huge amount of electricity that is produced mainly and effectively for the grid, and also for large high energy industrial operations, which is absolutely necessary if we're going to have meaningful progress in decarbonization. So the difference occurs in ocean energy, specifically wave and tidal, where there is really not a one size fits all, and such as the wind turbine. And instead, what we're seeing is that there's a wide variety of wind and wave, a wide variety of wave and tidal devices in development, which you're going to hear about shortly. And you'll see that many of these technologies operate in varying ocean conditions, some in very high energy, open ocean conditions, and some in shallower water, more protected conditions, and everything in between. So what this means for ocean energy is that ocean energy systems, particularly wave and tidal, and connected with other renewables, is that they're particularly well suited to provide a direct energy solution for blue economy businesses, industries, and communities. So if that's so great, then what is the problem? that's the million-dollar challenge. Unfortunately, demand for ocean energy systems in the blue economy is really underdeveloped. We're strong on the supply side, meaning that we have emerging technologies, we have investment in R&D, we have test centers, we have global peak bodies, and so forth. So all supporting the development, but what we're missing are paying customers. We don't have the markets and the end users knocking on our door, knocking on the door of the technology developers saying, we want your product. And that's where we want to make a difference and where it can make a difference for the industry. Next slide, please. So there are some considerations when we think about why there is a lack of market demand, and there are four main challenges. One is the first is awareness. Many of the blue economy businesses, communities, and industries are just not aware of ocean energy, and they're not sure what it is or what it's about or how it would even be connected to their operation and their needs. The second is accessibility. So even if many of these market or end users were interested in ocean energy, the next big question is, well, how do we find it? Who do we go to? How do we access this, and so forth? The third major item or barrier is affordability. So let's say that the markets do get the information, they're interested, but getting that real business and financial data to help them build the business case is still challenging. There is a lack of data. And then the fourth major barrier is having an effective delivery system for commercial projects, really being able to bridge from the technology development and getting the deployments with the markets. So yes, there are a few hurdles, as you can see. Those aren't easy challenges, and those are the things that we're working on. So I'm actually going to wrap up my part of the presentation at this point. At the end, after you hear from our exciting technology innovators, Alex will be sharing a little bit more about what AOEG's solution at an industry level is to build that market demand. So I laid out the problem. Alex is going to provide the solution. And in between that, I want to stop here and actually transition to our first presenter. It's going to be Chris Scheer, who is Associate Principal Engineer with BMT Commercial. And as I mentioned just before I turn it over to you, Chris, I just want to remind the audience, we have 8 different technology innovations to share with you. We're going to move pretty quickly and not have questions in between, but we will have a Q&A after all 8 are finished. So with that, I'm going to turn it over to you, Chris.
Thanks a lot, Stephanie. Yes, and thank you to the Blue Economy CRC and to the Australian Ocean Energy Group for the opportunity to present today. I'm Chris Scheer, Associate Principal Engineer at BMT in our Melbourne office, and I have the privilege of presenting 2 innovations that my BMT colleagues in Canada are developing with applications for decarbonising the blue economy through ocean energy solutions. So we see these innovations as having worldwide applications, and once development work has progressed in Canada, we'll be looking for opportunities in other parts of the world as well. Next slide, please. So to introduce BMT, we're a multidiscipline engineering, science, technology consultancy, and we operate in the defence, energy, environment, shipping, ports and logistics sectors. Initially formed in 1985 through a UK government privatisation, and we've grown organically and through acquisition since that time, and we're an employee benefits trust. And we're a key industry participant in the Blue Economy CRC, and a member of the Australian Ocean Energy Group. Next slide, please. So yeah, the challenges, BMT have identified two challenges where we saw an opportunity to develop new solutions. So the first challenge is the time and cost to develop a standalone renewable energy microgrid solution for remote Canadian communities. So at the moment, a lot of those communities are heavily reliant upon diesel generation, which is costly, has high carbon emissions, and has a risk of environmental leaks and spills. So there's more than 300 remote communities in Canada alone, which we see, there's a benefit there from adopting hybrid renewable energy systems, bringing more environmentally friendly, cost-effective solutions to communities who are not part of a larger power grid. And the second challenge is where there's a need to develop a persistent, rapidly deployed, autonomous and affordable surveillance solution for offshore waters for detecting underwater threats such as submarines. So these are two challenges that we've identified and have been doing some work on. So next slide, please. So yeah, the solutions that we're coming up with at the moment, which are under development. So we've been fortunate to secure development funding for both of these solutions. They're both at pre-commercial development stage. So the first is the microgrid interface unit, MIU we call it. So this is a standardized smart grid solution. So which includes energy management and distribution. So the key is that it's a low-cost solution for smaller scale demand, so less than, say, a 1 megawatt requirement. And the graphic on the side here shows how the MIU will be capable of integrating a range of renewables, non-renewables, and storage energy assets to provide for the required power demand. So the challenge of integrating multiple sources often requires a costly custom solution at the moment, whereas we're aiming to develop a more standardized solution, lower cost, and a system that will be autonomous, that can automatically synchronize power from a variety of sources, handling load management, and significantly reduce the reliance on traditional fossil fuel generators. So that's our first innovation that we're working on at the moment. And the second one is what we're calling the SEDN array, or Faraday wave energy generator. So basically this funded from the Canadian Department of Defence, and this would use wave energy, convert that into electrical power sufficient to power the instrumentation on board a surveillance buoy. So the existing surveillance buoys or sonar buoys, they're powered with a one-use battery, which when that battery is depleted, the buoy is sunk and basically wasted. So with the use of wave energy technology, the duration of deployment of these devices can be dramatically increased. So we're thankful for the support there of the Canadian defence industry. So next slide, please. So in terms of adoption, with the MIU, it's currently co-funded by the Canadian Ocean Supercluster and BMT, and we have a full-scale design, build and test project currently underway in Canada, which includes a tidal energy machine, which is in the bottom right of this slide. We see the broader application for the MIU is large, including numerous, remote off-grid communities throughout Canada, throughout Australia, throughout the Pacific. And then for the wave powered surveillance buoy, at the core wave energy generator part of that machine, we see that technology has a wide range of applications, powering offshore instruments, monitoring equipment, and other defence applications as well. Next slide, please. So yeah, just to wrap up, thank you again for the opportunity to speak, and welcome any questions about the two solutions that I've discussed today, and look forward to hearing from the other speakers. Thank you very much.
Just realized I was on mute. Thank you very much, Chris. It was really interesting technology, and I appreciate the introduction. Our next speaker is going to be Darren Powell. Darren and his colleague Dan Etherington are both co-founders of SmartBarge, and it's a very interesting technology in development. So over to you, Darren.
Thank you, Stephanie, and thank you everybody for the opportunity to share at the presentation today. I'm going to start with a video as opposed to slides. And then I'll fill you in on some detail after this. So enjoy.
Ross Garnaut is an Australian economist currently serving as a Vice-Chancellor's Fellow and Professorial Fellow of Economics at the University of Melbourne. In his book Superpower, published in 2019 by La Trobe University Press, Garnaut envisages Australia becoming literally a superpower in energy from renewable resources. He foreshadows that an abundance of cheap energy could be Australia's low-carbon opportunity to process its raw material iron ore and bauxite into exportable steel and aluminium. This in turn could lead to a new domestic industrial revolution in manufacturing, plus the export of surplus energy as hydrogen to Asia. Currently, renewable energy discussions focus on large wind farms, vast solar arrays, and pumped hydro. Massive capital funds have been raised and deployed for their development, boosted by remarkable technical advances over the last 2 decades. However, Garnaut's bold vision omits to mention the most predictable and regular of all renewable resources, the tides. The awesome power of the horizontal falls in the Kimberley is a consistent and persistent reminder of the potential of this perpetual, predictable and renewable resource. The SmartBarge is our answer to partnering with the regular pulsing power of the ocean and modern technology to harvest, store and deliver moving electrons. Electric vehicles, EVs, are now commonplace on our roads. Electric trucks, buses and other vehicles are arriving, and the infrastructure that currently powers these machines is moving too. And yes, all of these are electric vehicles. Some are on our roads already, and the others are arriving soon. The full-scale SmartBarge will operate in relatively shallow water with tidal ranges from 3 metres low to greater than 14 metres, and variable tidal speeds at 2 to 6 metres per second, featuring multiple vertical axis Gorlov type turbines capable of maintaining their power curves in turbulent water flows from any direction, DC to DC converters and maximum power point tracking electronics, scalable and containerised multi-megawatt battery storage for ease of distribution, all made in Australia. A fleet of smart barges could provide cheap renewable power to Broome, Derby, Port Hedland and Wyndham, currently burning fossil fuels for power, remote Indigenous communities relying on expensive diesel-electric power, bulk carriers waiting in the roads currently running their diesel-electric systems to provide onboard power, and emergency situations in coastal and riverside areas. The Smart Barge team are currently developing the twin tidal turbine 80 kilowatt-hour Smart Barge Test Rig 1, SBTR1, which will be deployed at the Kimberley Marine Research Station with the full support of James Brown from Cygnet Bay Pearl Farm, recently named Australian Farmer of the Year 2021. SBTR1 will allow for rapid optimization of turbine, electronics and battery systems, the testing of charging, discharging and remote monitoring systems, while also testing water and weatherproofing standards to IP68 and the development of safety protocols for the operation of Smart Barge, including loading and unloading procedures. Smart Barge, electrons on the move.
So that basically tells the story. We're a very early stage startup, as you can see, but we are being introduced to people who can assist with the design and development of Smart Barge. Just in a recent week or two, we've spoken to people at the University of Western Australia through our connection with Stephanie and Alex at the Australian Ocean Energy Group. Thank you for those introductions. I've had some terrific discussions with the team at the Wave Energy Research Centre, Oceans Institute Hydrodynamics Lab, and the plan is to develop initially the turbine concept, which is a vertical axis Gorlov type turbine, which has some interesting characteristics in terms of being able to maintain, as the video said, a power curve in turbulent conditions. And subsequently, the concept at the moment is to develop the test rig, get it deployed up in Cygnet Bay, and start testing the concept in terms of delivering electricity when and where required. And that's where we're up to with Smart Barge at this point. And thanks for the opportunity.
That's great, Darren. Thank you. Well, your concept is very innovative and certainly going to be the one to watch as you grow and scale up your innovation. So thank you very much. All right, our next speaker is Jonathan Fives, CEO of Carnegie Clean Energy. Take it away, Jonathan.
Thanks, Stephanie, and thanks to the Blue Economy CRC and AOEG for organising this webinar. My name's Jonathan Fieve. I'm the CEO of Carnegie. We're a listed technology company focused on harnessing ocean energy to make the world more sustainable. We've been doing this work for over a decade. We have subsidiaries in Scotland and Ireland, and we've got a growing team of highly skilled people here in Australia, but increasingly international in Europe and Canada. Next slide, please. So Carnegie's CETO technology is shown on the screen there. We see a buoy, which is the red part, we call the buoyant actuator, and that's driven by the forces of the wave. It's driven down and forward and aft, and also it pitches much like you would in a boat if you're out at sea. So those multiple modes of motion are really important in terms of the capture efficiency, because I guess megawatt hours are very precious in the game of trying to reduce the cost of energy. So being able to capture those multiple modes are really important, and that's the aim of this design, which is a little bit different from our previous design, which had only a single connection to the seabed. This has multiple connections to the seabed. We convert that motion into electricity through what we call the power takeoff system, which is kind of like a electric winch, which as the buoy moves, it resists the motion and produces the electricity. Of course, that comes out via the dynamic cable and then off to export cable back to shore or to wherever the demand might be. Of course, as you can see, it's deployed in arrays. And so, yeah, we'd expect to see farms of these things deployed in typical commercial plants. Next slide, please. So I guess, reflecting on the topic today, which is really markets and decarbonisation. So if we speak firstly about the grid market, the picture you're looking at there is our 3 CETO 5 buoys, which were deployed as part of the CETO 5 project at Garden Island. So that was a year-long trial of a very large scale. So those are 11 metres in diameter, each buoy. And it produced energy, which we sold to Department of Defence on Garden Island. I guess the conundrum is that large grids are by far the largest market, but they're also the most competitive market. With reducing costs of power, particularly of solar and wind, they're a challenging place to be until you can scale. But we know that CETO and other ocean energy technologies can be competitive with the right scale and also their characteristics of being, particularly in the case of wave energy, you know, almost continuous supply of power around the clock is really a great addition to the mix. Next slide, please. A really interesting market, which on the face of it would seem much smaller, and it is, but it's still a huge market, and that is the island market. And I guess we'd also incorporate with that sort of remote coastal communities, which are not grid connected. I mean, these are particularly attractive because, you know, they're sourcing energy from diesel, which means that they generally have a very high price of power that the communities there are paying. They also don't have the luxury of space, and also they're very sensitive to visual amenity. So what you're looking at there is one corner of Mauritius, and as you can see, I guess installing large solar arrays or wind farms is probably not a very attractive proposition for that community, yet there's an amazing amount of energy in terms of the waves hitting that coastline. And of course, a lot of islands are on the front line of climate change. You know, they're copying the greatest impact in many cases. Next slide, please. One that I sort of wanted to focus on really is what we call the demand markets. And it basically means where you have an offshore demand, and there's many of those, but the one that is indicated here is an aquaculture farm. So what you're seeing is the feed barge there, which feeds the salmon that are in the fish pens that are in the background. And yeah, I mean, their sustainability is particularly topical for them at the moment. You might have read the press recently. There's certainly been a lot of talk about their sustainability. And so moving offshore is quite an important transition for them in many cases for environmental reasons to reduce their impact. That's very focused if they're in nearshore conditions. So as they move offshore, though, the diesel that they generally, well, in fact, they all power these devices from, that presents various problems above and beyond the problems they already have in terms of the cost and fluctuation prices and so forth. You can imagine offshore with waves, refueling gets harder and more risky, and they don't really have the opportunity to use solar or wind. I mean, wind's one where they're generally wanting to avoid, mainly because they already have, I guess, enough environmental considerations on their plate. Adding wind turbines is additionally tricky, I guess, not impossible, but difficult. So this is an example of a hard to abate, I guess, environmental footprint, and wave energy here is a really good prospect. We've created a product called More Power, and you can see highlighted in there on the front of the barge two power takeoff systems, which have been essentially just moved from the CETO technology onto the front of the barge. And Carnegie's planning a project in this space, so stay tuned for that. But yeah, that's a really good example of a demand market, and one that I think Ocean Energy should be engaging strongly with. Next slide, please. Just finally, I just wanted to mention these two other spin-offs because they are very relevant to the blue economy industry. They're not explicitly about decarbonisation, although they relate to them. The top left is a wave predictor, which Carnegie's developed and tested in a tank, and that predicts the waves using neural networks or AI. And knowing what the waves are doing coming toward you, you can make really smart decisions controlling a CETO wave energy converter, or if you're, I guess, operating offshore, perhaps you're transferring people from a vessel onto a fish pen, it would be useful to know if there's some really big waves coming. And the bottom right is an example of implementation of a mooring tensioner that we're developing under a project with the Blue Economy CRC. And this is getting away from the classical mooring systems to a more advanced mooring system which maintains tension in the line for better station keeping. So that's a snapshot of Carnegie and its activities in the area. If you have any further questions, feel free to contact me.
That's great, Jonathan. Thank you for highlighting such great opportunities in the blue economy. That was a really good overview of what the potential markets are. So well done, thank you. All right, moving on, fast and furious. Our next presenter is Michael Byrne. He's Director of EHL Australia and also Vice President of Azura Wave. Over to you, Michael.
Thanks, Stephanie. Firstly, I want to say, as with everyone else, thank you to the Blue Economy CRC and AOEG for the opportunity to present Azura Wave Power. Now, to kind of set the scene, we began this exciting project back in 2004 as a collaborative effort between EHL Group's New Plymouth, New Zealand-based facility and Callaghan Innovations. Now, EHL Group is a New Zealand headquartered private company with decades of experience in hydraulic motion and control, specialised project design and fabrication. We've got sites in New Plymouth and Auckland, New Zealand, and I'm based down in Western Victoria in Australia. And we currently employ over around 50 full-time engineers, trades and support staff. After many years of projects within the oil and gas space, both on and offshore, we as a company wanted to focus on change and developing engineered solutions, providing real benefits as we all move forward to a decarbonised economy. We feel Azura is a good part of that solution. Next slide, please. Right, hopefully those videos will work. No? Okay. Okay, with the videos, the first one at the top is a bit of a cheeky one. It shows a bit of an inquisitive whale swimming past the Azura as it was being tested, one of the prototypes being tested off the coast of New Zealand. The second slide down, second video shows the power distribution cable that leads from the Azura to shore, and that was filmed while we were testing prototypes in Hawaii. And the third one down is an Azura prototype producing through around 4.5 metre swell and doing it quite easily. Now, the Azura is not your typical wave energy converter. It realises potential energy across both the heave and flow of the ocean, increasing its overall output and efficiencies. And that's what you can see in that diagram there. The diagram to the right of that shows the setup that we did in Hawaii during one of the prototype tests there. It is a 3-point mooring and it gives flexibility, absolute resilience and minimal impact on the sea floor. And that's a whole other area we're working on as well. The requirements of a decarbonised future cover a multitude of utility supply evolutions. And while we were developing the energy generation side of Azura, we also looked at the effects of climate change now and how we could provide a greater and more versatile solution. From this, we identified the need for a consistent potable water supply and designed a uniquely driven onboard desal plant. So within the Azura, you have the ability to have either power generation, power and water generation, or purely water generation. And that's all done on board. The pathway has been very, very long and involved as we designed, modelled and tested units, but we were working on some real key and guiding engineering parameters that we wanted the system to meet. That was one, it had to be modular, so it was easy to transport. It had to be simple, it had to be very versatile, it had to be robust, as everything does in the ocean environment, and we had to have a real ease of deployment to make it for initial deployment and also to make it redeployable. So we went through extensive prototype testing. It's been done off the coasts of New Zealand, Oregon, in the US, where we did some more wave tank testing. And we've had 2 greater than 12-month deployments at the US Navy's Wave Energy Testing Site, or WETS, as it's called in Hawaii. During this time, Azura was independently monitored and verified by the University of Hawaii, and we actually came back with better than modelled responses, and we continued to produce without failure through 2 hurricanes with waves over 7.5 meters. The other thing is Azura became the first wave energy unit or device to be certified to supply the US grid. Next slide, please. Now, markets is a very big thing, and sorry, I'll grab my bit of paper back. So when investing in the design of a new system, a focus is required on where we can provide the most impact and provide real solutions to a market with either existing challenges or emerging opportunities. Rather than build it and they will come, Azura is designed to meet the demands of a number of key markets. Now, I've identified these here on the screen for you, but you will notice at the center there is one of the key underpinning things that we work on, which is we're all about job creation and reduction in CO2. So primarily we see the benefits of the here and now for coastal and island communities, as previous speakers have alluded to. We see that they are struggling with old and unreliable utility infrastructure. We're also seeing the effects of rising salinity in their groundwater due to climate change induced sea level rise. And this is where our water and energy system can really come in and make a difference to their environments. Whether near shore or deep water based marine aquaculture can benefit from the energy supply afforded by Azura. As previously stated, this will assist in removing the diesel gensets currently seen on many of the offshore facilities. For the larger emerging offshore farms and processing sites, the ability to provide both power and water will provide a benefit for both the facilities and staffing on board. One of the other bits you'll see there, again, defence and scientific, as we see the ongoing development and requirements across research, monitoring and defence applications, the need to resupply or recharge unmanned underwater vehicles at sea is gaining in demand. Being completely autonomous with little sustainment required, a strategically moored Azura with underwater docking will provide a solution for this expanding market. Offshore wind farm projects are gaining in momentum, and as previous speakers have mentioned, it's one of those things where we can't compete head on. This is utility scale stuff. We're not there yet. But what we can provide is infill. Now, with supply cables and infrastructure already required, the addition of ocean energy will lead to a more consistent additional production and allow a greater amortization of costs to energy potential produced to be realized. And Stephanie will see that I've used a slide there that she knows I absolutely love, and we all do, which shows a number of different technologies being utilized. And this is one from Europe, and it shows the yellow being solar energy, the bottom line, the squiggly line being wind, and the actual line through the middle is wave. So you can see how everything complements each other. It's about technologies working together. And ocean energy can provide a better baseline in that mix, we believe. Next slide, please. Okay, so what are we doing now? We've secured another 50% of non-dilution funding from the US DOE for a commercial scale unit of 250 kilowatts for deployment back to WETS with the US Navy. Now, a lot of our funding along the way has been courtesy of the US Department of Energy and the US Navy. We're currently finalising engineering design for a combination hybrid water, energy and water-only systems. We're working on final engineering design for a pumped high-pressure water system to feed a hydrogen production desal plant in Hawaii. We're currently in talks with a number of opportunities around coastal and island communities in Western Australia, New Zealand, Mexico and Chile. The response has been incredibly positive from all of these markets that we've spoken to, especially the island communities with the water. What are our challenges? Well, we're retaining the technology and employment creation opportunities in Australia and New Zealand. We're really passionate about creating ongoing local impact versus the current imported solution imbalance. The other challenge, of course, with everyone is money. So we're currently working on securing further strategic and financial investment funding in support of Azura's ongoing commercialization offering and to be part of it. And we want people to be part of our exciting journey. We're moving forward. We're past the prototype stage. We're ready to go. And we're very keen to keep raising the visibility of the quickly developing technologies within the ocean energy and the reduction that we're all seeing in LCOEs within government and investment sectors to forward the whole industry. Thank you.
Thank you, Michael. That was really terrific, and really appreciate your, and I'm excited about the Azura technology and the maturity that you've achieved, the progression that you've made towards commercialization. So, and the markets that you have targeted are certainly very well targeted. So all the best. It'll be good to track your progress. All right, well, the next, our next presenter is Roy Mitchell. He's mechanical engineer with One Tide. Over to you, Roy.
Thanks, Stephanie. Yeah, like everyone, I'd like to thank the Blue CRC and the Australian Ocean Energy Group for allowing me to, I guess, present our wares and what we can do for the ocean energy future going forward. We're a Western Australian SME. Completely 100% self-funded since 2016. So all the technology, all developments that we've done has all been self-funded. We have no backers. So we're a slightly different animal to most companies, I guess. We've got lots of different capabilities. We've got advisory, we've got engineering capability. And one of our big things is technical limit engineering. So we look at project and we look at people's I guess companies, technologies with a different set of eyes, and we can help either help them move it forward or put a technical limit spin on what they can provide. We do efficient and on-time delivery with our concepts. We also do a lot of 3D concept modeling for some of the projects that we've been working on. We're 100% Australian owned and operated, and we're really an innovation company. So we develop our own products, but we also help companies innovate, and we can help design, deliver engineering solutions for efficiency and safety optimization. So we've got many years in the oil and gas industry, and that's what we kind of fall in the back of that experience. Next slide, please. So decarbonisation, one of the big things for what we do is we don't just throw in a greenhouse gas emission reduction plan after the project's happened. We actually design our products from scratch for reducing CO2 minimization right from day one. So all our products have the whole life cycle for CO2 minimization built and designed in, all the way through from concept innovation. And these are scaled for sort of future island growth, climate change effects, which we all know are going to increase. So that has to be taken into account now rather than later on. Engineering compliance, manufacturing, the logistics train for that project and for that product, it all gets checked for CO2 reduction. The offshore construction side and the onshore construction side, the whole way through, we look at the greenhouse gas footprint minimization. Next slide, please. So this is go back one. That's it. So this is an overview of a project that we are currently working on. It's a remote island project up north. Now, if we work our way through from the left-hand side, we're showing two different tidal systems here. Now, they're pictures, but we're not really concentrating on the tidal system. We are mainly concentrating on the mid-ocean junction box and the microgrid capability for that system. As we all know, ocean energy systems they're very difficult. They can be problematic as far as failures and getting them to work properly. So what we are trying to do with this project is we're reducing the single point contact of failure. So if one of the systems was to fail, then we'll have a backup, at least a backup system that we can tie into to continue that supply of power to the island. One Tide developed our own microgrid system. We've had a microgrid system since 2015. We developed the system back then for disaster relief and to provide remote communities and remote islands a microgrid power supply. That microgrid system takes all inputs in. We can take solar, wind, hydro, we can take the grid in, we can even take a diesel generator in, and that system is going to be used on this project as the hub for providing that energy source to the island. From that microgrid, we will be then planning to offtake a small commercial hydrogen system. So that hydrogen system will be used to provide a refueling supply for a small crew type vessel. Now, the reason for that is we're not looking at this as a large mega project. It's a small commercial project that will have the ability to scale up in future, but it's a project that's doable, and we can actually provide the system very easily to showcase how marine refueling will be done and can be done and can be scaled up. So that's just a little bit of an overview of the project. One other thing I'd like to mention is the location of this island that we're working on it's got an 11-meter tide. So one of the other potential areas of energy generation is actually using the breakwater. We're looking at using the breakwater as an energy generation supply using that 11-meter tide. So that's really part of the project that we're working on just now. It's pretty exciting, and it's moving forward quicker than we expected, so which is good. You can move on to the next slide, please. So one of the key challenges is dealing with ocean energy systems in Australian waters. As the people in Australia will know, we have massive tides here. We have very extensive marine growth that happen with the tropical marine environment, and we also have to deal with cyclonic wave and wind conditions. So developing ocean energy systems is very complex down here, but it's once you've cracked that nut, the benefits are vast globally, because if you can have an ocean energy system that can survive down in Australian waters, you can take that system anywhere on the planet, and you know it's going to work. Some of the systems developed and deployed and proven in our waters, there's been a few down here, but I believe there's a lot more availability for systems from the UK and over in America to bring the systems down here and be trialled and tested down in Australian waters. The project that we're working on, we've got some funding partners. That's always difficult for big projects, is getting the funds to move on with these projects. So that's always a challenge. The market response for this project has been fantastic. We've got federal government support, and the state government's really positive on it. We've got mines, the traditional owners of the land are all positive about the project. We have academic approvals, and the customers, the off-takers on the island, they're all super positive about having a green energy supply to the island. So this is a fantastic project, and I'm really looking forward to be able to showcase this to the world, to show how this can be done. Next slide. I think that's the end. Yep. So that's me, and thank you very much for everyone taking the time to come and have a look at this webinar.
Thank you, Roy. Really interesting, and thank you for sharing and introducing the project you're working on. It's certainly something to be tracking. What I especially appreciated, though, on the other side of the story is the complexity that it takes to consider the supply of ocean energy to, a land-based requirement or market. And clearly your illustration shows all the a range of considerations that need to be taken into place, which makes it very challenging to build that market demand. So thank you for pointing that out. All right, moving on. Our next speaker is Sam Layton. Sam is the CEO of Bombora Wave Power, formerly, sorry, Sam, I'm going to steal a little bit of your thunder, but to say you are Australian founded, but currently working in Wales. So I'll let you take it away.
Great. Thank you, Stephanie. Good afternoon, and thank you. And thank you also to Irene and the Blue Economy CRC. So yes, Bombora started back in Australia in 2012, and we did tank testing down at UTAS, went through mid-scale trials, and gradually built a confidence around the technology. In 2017, we decided to move the operations from Australia to Europe to take advantage of, I guess, the more positive reception for wave energy development and support the funding as well. So we moved the whole company to Europe. We've grown the team, and we're now quite active in Europe. Next slide, please. So I guess we now have between 20 and 30 staff, depending on the time of year. As I mentioned, we've gone through small and mid-scale demonstrations in Australia. We're right now in the commissioning phase of a 1.5 megawatt wave energy converter here in Pembrokeshire in Wales. So this is a very expensive project. We were fortunate to secure funding from the European Regional Development Fund to back that project. And we've gone through basically 2.5 years of design, development, procurement, site consenting, all the things you have to do to get a project like this up and away. And right now we're in the final assembly phase. So you'll see here at the bottom of the slide here, some of the components going through the final assembly phase. We are basically going through the debugging phase of this project right now, and we'll be deploying that early next year. So I guess this is, in terms of our taking our product and going through the validation process, this is the final stage of our product validation. Next slide, please. So I guess in terms of the market, so it has been quite an uphill battle in terms of bringing wave energy to the market. We've been fortunate, as I said, to get grant funding to support the initial projects. But as we move forward beyond that demonstration and proof of the technology, we need to go into an area where there is effectively a tailwind. And in terms of decarbonisation, the DNV has written some great reports about the progressive adoption of renewables, where renewables grow quickly. Wind becomes a more and more dominant part of that as, I guess, land becomes more difficult and we seek to get better and better capacity factors. The industry is moving offshore, and as you go offshore, it gets deep, and then you need to go floating. And so what's happening right now, particularly because led in Europe, is this progression to offshore floating wind. Next slide, please. So what we're seeing is trials being conducted and smaller scale projects, around 50 megawatt type scale being developed. So you'll see people like Principal Power, Stisdale, people are doing projects and people are doing trials of these sorts of floating technologies where you go offshore in depths of water greater than 50 meters. And I guess these projects are getting up and away. They're expensive, typically £5 million per megawatt to deploy and commission. And the industry, though, has been going down this single capture platform pathway, where they're putting wind turbines on top of very large platforms. We have cooperated, or let's say we've formed a collaboration with Technip FMC, the very large international engineering company based here in Europe and with operations in Australia and basically everywhere in the world. So we're now in an alliance with them to bring a combined wind plus wave technology to market. So this is where we take the technology we have developed here in Wales, couple that with a commercial wind turbine, put that onto a floating platform, and basically create a dual capture platform. So we use the infrastructure that is required for the wind turbine, and we have then a dual capture system. Next slide, please. So, as I mentioned, this gives you double capture, which makes better use of the infrastructure you have paid for. So the platform, the mooring system, the electrical grid connection, and so on. I thought this leads to more competitive project bidding. You're getting roughly 50% more power from your lease area, and these lease areas are becoming hard to find and very expensive. And as was mentioned a moment ago, you get much more power consistency. So by combining the wind, which is quite consistent when you go offshore, but there are still times of calmness. But if we can fill those gaps with wave power, then you can increase the base load and create this base load, but you're also able to sell your power at times when the wind isn't blowing, which enables you to attract a better pricing for your power. So we are, I guess, going through the process of taking that to market. So we have our Pembrokeshire project, which is going through the final commissioning phase. We are in parallel going through the pre-feed, feed with a view to then project financial close on a project with Technique FMC and taking this to market. And I guess you'd say we are now on a pathway, on a trajectory, which takes us into these very large projects. And with the goal of bringing volumes up, costs down, and becoming globally competitive. And for those who want to see more about these projects and what we're doing, there are links in our presentation, which I'm happy to share, which enable you to access. There's a good walk around video of our assembly site, and there's also promotional videos for our dual power platform. Thank you very much.
Thank you, Sam. Gosh, I was just thinking as you were presenting that I remember when Bora was first formed, and I'm sure it doesn't seem like yesterday to you, but it's fantastic to see the progress that you've made. And I'm especially impressed with the idea of being focused in a real growth market, which is offshore wind, and finding that synergy. That's a really great opportunity. So look forward to exploring that more further. All right, moving on. Our next presenter is Terry Moan. Terry is the founder and chair of the Australian Microgrid Centre of Excellence. It's a great concept, and I'm excited to hear more about it. So over to you, Terry.
Thank you, Stephanie, and thank you to the Blue Economy CRC and Australia Ocean Energy Group for allowing me to share some information about us. Our organization was founded this year, believe it or not. Seems like much longer, but we launched the business in April, and we've had quite a number of accomplishments since then. Please go to the next slide. I'll start talking a little bit about the organization and what our intentions are. The Center of Excellence is not trying to create something new, but is trying to advance the state of the art. We're focused on the events that are occurring globally around digitization and decarbonization, and how do we incorporate that into the edge of the grid solutions. We're seeing that power is flowing bidirectionally in many instances, not only on utilities, but in the nature of localized onshore communities. So we're trying to find out what do we need to do as an industry to advance that state of the art. So we're focused on the energy environment arena. We started out here in Australia because there's just such a large number of microgrids already in existence. So we want to take lessons learned and work with existing developers and stakeholders who have microgrids and understand what the current challenges are and look at what do we need to do to move the needle forward. Also, we want to try to establish an economic base around the microgrid business. Right now, traditionally, if you're a power engineer, you look to develop work with an EPC or with a large utility. We think in the microgrid business and microgrid space, there's a huge growth opportunity. And so what we want to do is create that economic base to attract more people to work in that space. So one of the things that we do is we are focused on education. So we're working with universities and trade organizations to certify people who are interested in the engineering field, and then figure out how to provide them with the tools that they need, equip them to conduct business in the microgrid world. Another thing that we're focused on is looking at all the services that microgrids can provide. Services are not only specific to the consumers within the microgrid, but we can export capacity outside of the microgrid to other interests. They could be other microgrids, they could be the local distribution system, they could be the wholesale market. So there's a whole range of different stakeholders. We're looking at how all of those play into the microgrid arena and looking at how the industry itself grows to accommodate all those interests. We're also interested in commercializing microgrids that started out their life in a research mode, helping those entities and stakeholders advance their capabilities so that they can replicate their system in multiple instances, particularly for what we're talking here about ocean energy and in the Asia Pacific area where we live. We see tremendous opportunity for businesses that become successful in a specific area, helping them replicate their business model in multiple geographies. Another thing that we're focused on is helping and assisting funding different types of research. So we're working with the grant organizations to consolidate funds and to make them available specifically for microgrid research. And also another part of our grant organization is to fund the tuition of students who want to learn more about what we're doing in the state of the art of microgrids. Can we go to the next slide, please? This is kind of our orchestration of all of our business in pretty much one slide. We're talking about how we're creating a visualization and showroom where we show how microgrids are evolving in a state-of-the-art scenario. We also are looking at how we create a hub that brings together innovation centers from Australia and possibly around the world. We can showcase what other innovation centers are doing and have a single place that all institutes can present their information. And of course, we would want to share our capabilities with other institutes wherever they may be. We are very interested in helping demonstrate technologies, particularly those we're talking about today. We see that there's a huge opportunity working with ocean energy, and we actually have a project that we're working on with NERA and Australia Ocean Energy Group to create an innovation center specifically for some work they're doing. And it's a part of a hub of the larger innovation center that we're constructing. I mentioned the fact that we're conducting research, so we're working with a number of research universities to identify the types of curriculum that need to be placed in preparation for the students that need to get into this industry. Not only are we looking at electrical engineering, but we're looking at what's the transition between smart grid and electromechanical systems. What are the issues around DC to DC based microgrids? We think there's a lot of opportunity for eliminating part of the the electrical kit that goes into microgrids by eliminating the transformer. So if we can figure that out through research, we're going to develop those types of solutions. We definitely want to focus on evolving our research into demonstration projects. We actually have one of them in place right now here in Western Australia. We think that we will generate new intellectual property coming from these research programs in our demonstration programs. And for those students or professors who wish to take their idea and turn that into a business, we will nurture that, and we'll bring in the incubator investors to help them create new businesses and new jobs around their ideas and technologies. I mentioned the fact, number 5 on the slide, developing workforce training. Not only do we do work with the TAFE organizations, but we're looking at business schools as well. What are the types of education that facility owners need to understand if their facility could engage with a microgrid? What are the nuances with the microgrid that's different than the traditional ways of delivering energy? So we're working on a whole range of different curriculum, trying to figure out what the industry needs, but then satisfying that with the educational requirements to help bring that along. I did talk about the grant organization and subsidizing workforce and the industry hub and the innovations around that. One last thing I wanted to mention is that we've just recently announced a month ago that we will now be providing feasibility studies for any nonprofit organization, typically Aboriginal outlying and unconnected to the grid type of communities. We'll provide feasibility studies at no charge. We have a team of engineers that provides that, and we have quite a number of tools. So we're working with a whole range of communities. We want to advance the deployment of microgrids under all circumstances wherever possible. And so this industry hub, this center of excellence, is to capture all of those various elements into a single purposed built organization. Currently, we're up to 40 partners, 40 members. It's all industry driven, and we look forward to working with the public sector in the future, but right now we're strictly focused on the private sector, just supporting the industry growth. And like I said, advancing the state of the art for microgrid deployment. So again, thanks for allowing me to speak a little bit about our organization. I think it's going to be a really fun time in the near future. So thank you very much.
Thank you, Terry. It's really great. I appreciate you introducing the center. It's very exciting. And as we talk about and think about integration of ocean energy systems, really understanding how microgrids work and having that connection to the knowledge and the expertise and so forth is critical to success. So I look forward to future collaborations. That's great. And finally, Tom, thank you for your patience. I want to introduce Tom Dennis. He's the co-founder and executive chair of Waveswell Energy. So over to you, Tom. You're on mute, Tom.
Thanks, Stephanie and Irene, for allowing me to present on Waveswell's technology here today. Next slide, please. Waveswell Energy Limited is a public unlisted company, Australian company. We were founded in 2016 to commercialise the unidirectional oscillating water column technology that we have. Whilst our head office is in Melbourne, we do have people spread across 3 different states. As I mentioned, we have a unidirectional oscillating water column technology. Now, oscillating water columns themselves have been around for quite some time, but they've always been bidirectional, and that has inherent problems associated with it. We've now developed the first unidirectional version of an oscillating water column, and we have a unit deployed at King Island. All of the photographs you'll see are of our unit that is at King Island operating at the moment. So next slide, please. The technology, as most wave energy technologies do, generates clean, sustainable energy from the ocean, therefore reducing carbon emissions. Now that means that technically it's classified as a climate change mitigation measure. However, the technology can also double as a form of coastal protection, operating as a breakwater or seawall, particularly if you place them side by side. And that ability to prevent erosion that will become more prevalent in various parts of the world due to climate change induced extreme storm events and sea level rise makes the technology also a climate change adaptation measure. And I think it's one of the only types of technology that can perform both tasks. It's efficient, survivable and accessible, and that makes it cost effective. Now, the efficiency, survivability and accessibility have been problems in the past for wave energy technologies, and something that we've focused on getting right in this particular instance. There are no moving parts in the water at all, which minimises the impact on marine life, but was critically important in terms of operations and maintenance, and it plays into that accessibility aspect as well. Our UniWave 200 unit is now generating electricity on into Hydro Tasmania's hybrid grid on King Island, and has been doing so for the last 3 months since June 18th. In fact, as I speak, it's operating right at this moment, providing electricity to the homes, businesses and industries of King Island. Next slide, please. The applications include mainland grid generation, displacing diesel, of course, desalinated water and hydrogen production, potentially a big application of the future. And as I've mentioned, coastal protection and breakwaters. It's already competitive with diesel generation. And when incorporated into breakwaters and seawalls, the shared costs will result in additional commercial viability. As more commercial capacity is installed, it's expected to become competitive with offshore wind earlier than the others, but eventually also the aim is to be cost competitive with solar and onshore wind in mainland grid applications. Final slide, please. There's been a lot of interest in the technology from energy companies and government authorities and the press, of course, both domestically and internationally. The US Department of Energy requested to collaborate with us on the King Island project, which they're doing at the moment, the purpose being to evaluate the technology for use in US waters. A few months ago, we were contacted by the World Economic Forum requesting footage and permission to produce a video about the technology for use on its social media sites. And various authorities in other locations, particularly Alaska and the Maldives, are very interested, both from the perspective of producing cleaner and cheaper power than their current diesel, but also they both have coastal erosion problems, particularly the Maldives, which as the lowest lying nation on Earth is in some danger of disappearing if it's not protected from the extreme events, storm events that are likely to occur in the future. So yeah, you've seen some images of our unit at King Island. As I say, it's operating at the moment, producing power. So we're looking forward to moving on from there. So thank you for listening.
Thank you, Tom. It's been so great to see your progress, and we really look forward to tracking your success as you continue to grow and expand into the different markets that you've spoken about. You certainly have a unique application in terms of looking at breakwaters and coastal erosion. So that's all very exciting. Well, everyone, this wraps up our innovative presenters, or technology developers talking about their innovations, and I hope you found it as fascinating as I do. I'm really proud to be working with all of them and watching their growth and success as we progress. And I just want to remind you, this is, we're now going to stop for about a short Q&A. I'm going to hand it over to Irene to manage the questions and to interact with our panelists. And then we're going to end with one more presentation from my colleague, Alex, who's going to talk about and share the industry's approach to helping drive market demand for ocean energy at the industry level. So I want to thank all the presenters. You did a fabulous job, and really excited about all your progress. So over to you, Irene.
Thank you, Stephanie. Thanks, everyone. Really valuable presentations, and I think very informative. And we've had quite a lot of questions in the Q&A that are jumping in and asking questions about not only your technology, but your projects as well, and some of the challenges associated with developing wave energy projects as well in Australia. There's a question here that I'm happy to throw open to all of the panel around the challenge of future financing to get these projects to commercial market stage with your technologies. And the question is, you know, what type of funding is required? Is it venture capital? Is it equity? Is it debt? You know, is it through grant funding opportunities that you can look at as potential ways to continue to finance your projects in Australia? And what's your position and your opinion on that, and what could help you?
Well, Irene, I'll jump in there. From where our position with Azura, we're looking at more the venture capital and equity funding rather than more debt funding as such. Grant funding's great, and we've been very fortunate in our background to get some great funding with the support of the US DOE, but and which has all been non-dilutable funding as well, which is great. But a lot of the funding that is available is always co-contribution. So it's coming up with that other amount there, which can also be a bit of a challenge from time to time as we're moving forward into larger projects, larger scale, larger dollars. So it's really that venture capital, finding those people who are passionate about what we're doing, willing to come on that journey with us, as well as the potential ones who want to then get in on an equity stake. Hope that answers the question in some way.
Thanks very much, Michael. Does anyone else want to add to Michael's response?
Yes, I'll jump in.
Thanks, Sam.
In terms of our journey, so we've gone through for financing our company, we've gone through the whole range of family and friends investment earlier on, through a strategic investor who came and took a good position in the company and helped us grow. And we're now going through another round of raising capital. So yes, we're obviously pre-revenue, and this makes it so you do need equity to fund your portion of these projects. However, these projects are expensive. I think I talked about in my presentation that our Pembrokeshire project was a £20 million project. So a very significant amount of money has gone into this project. And so grant support, those sorts of support mechanisms are critical to allowing those sorts of projects to progress and bring this technology to market. I guess beyond that, then you need revenue support schemes which enable you to go through the low volume phase when your costs are high and you have expensive power to sell. And Jonathan mentioned, the going after special markets which have, displacement of diesel and so on. These are good markets to go for to help bridge that gap. But we've found definitely that we need to be targeting markets where there is a government support scheme, revenue support scheme to help these early projects get going, enabling you to build volume, bring down your costs, and then become globally competitive. So this is the end goal, of course. We need to sell competitive power, but you do need help to get along that pathway.
Wonderful. Thank you very much. I'm going to ask a more technical question, something that a few people have picked up in the Q&A around the benefits of wave energy and desalination. And this is a topic that I can see for many of the technologies is really important. And I know that there's plenty of examples, for example, with Carnegie Clean Energy, with the CETO5 device, with Azura technology, talking about opportunities to look at not only energy solutions, but also looking at water-only systems for desalination or even hybrid water and energy. And so my question to the panel is, it's been mentioned as a potential alignment with wave energy technology. How complicated is it actually to do this with wave energy technology? Does it add to the cost, the LCOE and the CapEx to develop desalination systems alongside wave energy devices? And is it actually the most energy efficient way to desalinate water, in your opinion?
I can jump in here on this. Desalination of water is very easy. The issue with using wave energy to desalinate water is that's actually, and I'm just being honest here, it's actually a very inefficient way to desalinate water. When you're desalinating water, you can desalinate water using a low energy supply. So when you're using a renewable energy supply to desalinate, you have to have a very efficient desalination system. That is the optimal way to desalinate water, is use an electrical supply to desalinate water onshore, where you can actually service it and maintain it very easily, and just use the efficient desalination system. That's the easiest and the most efficient way to desalinate water, big volumes of water.
Thanks, Roy. I might throw it over to Jonathan for this. Jonathan, you've got some experience with this, with previous deployments that you've done where you've done both water and energy. It'd be great to hear from you as well.
Yeah, thanks, Irene. So, yeah, as you mentioned, the CETO5 project, it produced hydraulic energy offshore. So it was basically a water-based fluid, not seawater, but freshwater-based fluid. And that came ashore through a pipeline. So we had a low-pressure circuit, high-pressure circuit, and onshore we were able to essentially tap off the energy by passing the high pressure through a hydraulic motor into the low pressure circuit, and that hydraulic motor then drove the pumps that would, I guess, pressurize the seawater that would work in a traditional reverse osmosis plant. So we did that in the CETO5 project. And the idea is that it kind of cuts out that conversion from wave energy then to mechanical energy, to hydraulic energy, then to electrical energy, and then back to hydraulic energy in the seawater circuit. We were jumping from that kind of hydraulic energy straight across into the seawater circuit and missing out at least 2 steps in energy transformation. So logically, it seems like a really good idea. There are challenges, though, and I think the reverse osmosis desalination industry is very well developed, and they have products that are very cost effective for the sort of traditional way of doing it, which is electricity in, salt water out. So electricity in, fresh water out. And so, yeah, I guess that's the challenge. You really need to have, I guess, a huge benefit, a distinct benefit in skipping a step and introducing a more bespoke way of doing things to compete and outcompete the traditional ways of doing things. And we felt like that the flexibility you get with converting to electricity and using conventional plant was actually better in our case. So that's the reason our new CETO technology converts to electricity, and then that electricity can be used for a variety of things, one of which is desalination. I will just add, there are benefits, though, of co-locating wave energy and seawater desalination beyond, I guess, the energy part of it, and that is the hypersaline discharge that has the very salty water going out, needs to be installed and can be installed alongside export cables for wave energy, as well as the seawater intake if you're drawing the water from the sea. So there's very much, I guess, project benefits from co-locating these systems, but at least for our technology, and I suspect for many technologies, interfering in the normal desalination kind of supply chain and operation is challenging.
Thanks very much, Jonathan. I might just throw it to Michael as well, Byrne, who I know would like to say something, and then we'll go on to Alex Og, who's going to give us the next presentation.
Thanks, Irene. You know me too well. I always like to say something. And Jonathan's really hit the nail on the head. It is a challenging environment to do RO at sea, and what we've actually done is taken traditional RO, reimagined it, reinvented it, and taken out a couple of those steps. So we do have a lot of minimal energy loss along that. So we can do that at sea quite efficiently, but also we're looking at pumping high pressure seawater straight to an onshore desal plant. Again, we're removing the need for those large pumps, etc. elsewhere. So there are a number of ways to skin this cat, but it's just going to, as with a lot of our technologies and a lot of what we're doing, it's going to be horses for courses, and each site will be slightly different as to what is required.
Thank you. One of the reasons for the question is that when we go offshore and we look at offshore industries, we will have a need not only for energy at site, but maybe also fresh water as well for different applications. And of course, in developing a microgrid solution or the production of hydrogen offshore, desalination will be a really important part of that whole equation. And so that's one of the reasons why I think wave energy provides an opportunity really to explore that further. I'm now going to actually go over to Alex Ogg. I know there's plenty of questions in the Q&A, and I welcome our panel members today to go in and answer some of the questions that have been presented today. So Alex, I'm going to introduce you as well as part of the next part of the session. Thank you, Alex. Alex is working with the Australian Ocean Energy Group as part of the Marketplace Program Manager. And I know that we're going to hear a lot about Alex's work in this area as well. He's had a long history working with NERA as a program manager for ocean energy, and he's been, currently focused on the development of integrated ocean energy microgrid in Western Australia's Great Southern, in collaboration with the Australian Ocean Energy Group and UWA's Wave Energy Research Centre, and of course also now the Blue Economy CRC. So I very much welcome Alex to the floor, and I'll hand it over to you, Alex, and we'll have a few minutes as well afterwards to take a few questions as well.
Brilliant. Well, thank you, Irene, for the introduction, and thanks to the Blue Economy CRC team for their super smooth organization and for their invitation to AOEG that's made this event possible. And I know that 2 hours requires a very long attention span, so thanks to all of you guys for hanging in there. Now, I can't pretend to compete with my colleagues on the discussion of the technical elements of ocean energy, but I'm just continually amazed at the quality and the diversity of the work our members are doing. So fantastic presentations, one and all. That was great. I'm going to lighten this up a notch and bring the conversation back to the very non-technical supply and demand discussion where Stephanie left off earlier. And then just briefly present what we see as part of the solution to stimulate demand and accelerate adoption for wave and tidal energy in a technology agnostic way. And to help frame that discussion, I'll just share a little personal reflection on the de facto, or perhaps better stated as the default evolution of renewable energy technology in general. Slide, please, Leslie. So my earliest memory of sustainable energy alternatives came as I was leaving high school and choosing that difficult career path direction for university in 1980. And I remember I was watching television, fascinated, as then President Jimmy Carter, in a really highly publicized event, was showcasing the 30 or so solar panels he'd installed on the roof of the White House in Washington, D.C. And I thought this was just amazing. These weird looking contraptions use the power from the sun to provide energy to the laundry and the kitchen facilities supporting the president's family and his staff. This was a really high profile event which attracted global attention. And it did have an influence on my interest in studying environmental science in my first year at uni. And then we fast forward just a handful of years when the incoming President Ronald Reagan had the solar panels removed. And just as publicly, I might add, the United States, after all, having its roots firmly planted in the sea of oil as one of the major drivers of the American economy at the time. And so Jimmy Carter's momentary dalliance with environmental sustainability quickly faded from the resources agenda and the corporate memory of most of the American public, and also brought an early end to my career dreams as an environmental scientist. And then nearly 3 decades later, the Obama administration brought sustainable energy back to the surface of that bubbling and heated climate change debate. And once again, the US White House was powered with renewable energy from the sun. Next slide, please. So what happened in those 30 years between relative technological readiness and the mass commercialization of solar energy? And why indeed did wind generation also take decades to achieve mainstream adoption? And the question really for our policymakers, who are someday destined to find alternatives to coal, gas, and diesel-reliant economies, are we content to wait until 2030 or even 2050 for wave and tidal energy to find its position, to connect with and deliver to its natural markets in the blue economy? And really the question for us in this urgency of climate action and decarbonization of our ocean economies, can we wait for politics to catch up and to create those permissive policy settings to advance the requisite R&D and technical development to commercialization stage in Australia? Next slide, Leslie. So really, isn't the race for 2030, the global net zero emissions targets for 2050, aren't these a bit of a beauty pageant at the moment? And I think you'd all be familiar with the contestants. We have the aging but timeless beauty of hydropower, used for centuries and commercialized for electricity production in the mid-20th century. Still a favorite with some judges. And of course, Australia's reigning queen, solar power, with a levelized cost of energy that's going to make her hard to dethrone. And then there's the up and coming underdog, wind energy, moving from strength to strength as it positions for transformation from a secure land base to the attractive but uncertain home offshore. And of course, today, all the spotlights are on Miss Universe, hydrogen, as a salvation and delivery mechanism for all things renewable. Slide, Leslie. But all jokes aside, in reality, Australia's transition to clean energy alternatives shouldn't be about competition. It's really about synergy. It's about the benefits that come when you combine wave or tidal energy with other renewables in holistically planned integrated systems. And Michael touched on that point earlier. It's about delivering sustainable energy to blue economy markets, markets where energy is inherently unreliable, expensive, and often reliant on burning fossil fuel. The future is about partnerships and long-term vision, combining oceanic food production, carbon sequestration, and energy generation in codependent ecosystems. Wind, wave, tidal, seafood, algae, kelp, bioproducts, blue carbon, green hydrogen. The real contest is how to integrate these, how to leverage infrastructure and the always contested marine space to create value and multiply benefits for our future's ocean-based economies. And this blue economy vision is where ocean energy becomes a contender and finds its first niche, as a number have alluded to today. I'd argue that there's no better place for this future thinking than here in Australia. And just as Sam mentioned, in other parts of the world, we see the European Commission creating new funding streams to facilitate ocean energy technology and offering substantial prizes for development of renewable energy islands and projects such as Bombora's Wind Plus Wave model. In July this year, the US Department of Energy announced $27 million in federal funding for R&D projects to convert energy from ocean waves into carbon-free electricity. We see similar initiatives, tariff schemes, and incentives being prevalent and gaining momentum in Scotland, England, and Canada. And thanks to Tom Dennis for this brilliant action slide of the UniWave 200. I know you've seen it before. Next slide, please, Leslie. So I hope this context helps explain why we at the Australian Ocean Energy Group believe we need a catalyst to move the dial for tidal and wave energy in Australia. A catalyst to cut decades off the default time lag between the types of developing technology we've heard about here today and the curious and motivated energy markets. And this is particularly relevant to the blue economy CRC participants and those blue economy markets who may or may not be aware of those benefits that ocean energy can bring to their decarbonization transitions. So to that end, AOEG is seeking to build a disruptive tool in Australia's Great Southern region, a tool to be a catalyst to stimulate appetite and accelerate this market uptake by creating a world's first resource. It's disruptive as it's not an either or energy proposal or a beauty contest. It's an and proposition indicated by its name, the Integrated Ocean Energy Marketplace. And we're calling it a marketplace as it seeks to address that supply-demand imbalance that we talked about earlier, that chasm between developing existing technology and its end users, matching like needs to compatible solutions with the ability to model, design, and deliver integrated microgrid-based clean energy projects to zero-emission hungry markets. Next slide, please. So just really briefly, the three elements that we talked about earlier, we call these the 3 A's. What we're trying to create with this marketplace is awareness, market awareness, government, policymaker, supply chain, and investor awareness. In other words, what is the technology and how can it provide solutions to market needs and create demand? Well, the marketplace will provide resources to educate, inform, and advise those end users on optimal project scenarios. And in parallel, it will demonstrate some of the relevant uses for that energy that we've talked about today, such as seawater desalination, green hydrogen production, and zero carbon refueling stations. Secondly is the issue of accessibility. So where can end users and supply chain stakeholders, and the general public for that matter, see a working system, and from that understand how their specific energy needs can be met? Who can advise them of the best options? Where can they get the products? The marketplace will provide the data and a venue to digitally connect or to visit in person, to see, touch, smell, and feel a multimodal energy system with a microgrid at its core. And then to use that to plan and connect with technology suppliers, to design and commission a system which meets their future requirements through project delivery partnerships. The resource will also provide public education through demonstration of cutting-edge complementary technologies such as kinetic energy storage and offshore recharging. And finally, that perception of affordability. What are the costs and benefits of an integrated marine energy ecosystem, and how do they complement existing or other emerging alternatives? The economics are currently unclear and go far beyond that simple price of electricity. In its digital form, the marketplace will house data on device outputs, costs, and risks with modeling capabilities. So scenario planning can explore the cost benefits of an integrated ocean energy system on a case-by-case basis and design bespoke solutions to meet the future needs of market users. So by addressing these three elements and reducing the barriers of knowledge, access, and financial risk, and by forming strategic partnerships in sectors such as offshore wind, aquaculture, and green hydrogen, the marketplace can leapfrog the decades-long adoption curve typically faced by developing renewables, starting now. And now, without further belaboring the point, I'd like to give you a visual introduction to the integrated ocean energy marketplace. And it's my great pleasure to premiere a very short video at its first public showing. So if we can make the technology work, I'll hope you enjoy it. Let's see how it goes.
Thank you very much, Alex. So Di Hazelwood, if you could share the video, that would be wonderful. Thank you.
Climate change is the defining issue of our time. Unless we change the way we produce and consume energy, life as we know it will change forever. The overwhelming need to decarbonise and transition to sustainable, resilient economies has already sparked rapid growth in solar, wind, and hydrogen technologies. But there's one source of power with huge potential to consistently and predictably produce clean energy: our planet's vast oceans. What sets ocean energy apart is the ability to integrate with other renewables, adding consistency and complementary energy to the supply. The high energy density of waves and tidal streams can provide reliable baseload energy, overcoming the intermittency challenges when combined with other renewables. This means ocean energy has the potential to reliably and efficiently sustain diesel-reliant blue economy communities for industries such as aquaculture, ports, marine transport, fishing, and coastal monitoring, and can provide clean power to decarbonise offshore gas production, desalinate water, and produce green hydrogen. The Australian Ocean Energy Group, with the support of National Energy Resources Australia and Climate Kick, aims to accelerate the adoption of wave and tidal energy by creating the world's first integrated ocean energy marketplace to drive market awareness, improve accessibility to technology, and ensure affordability. This novel approach will catalyse commercialisation of ocean energy by changing the dynamics from technology push to market pull. The integrated ocean energy marketplace will be a hub where supply and demand can intersect to generate awareness, allowing renewable tech companies, specialist suppliers, and potential customers to connect and model solutions for transition to meet net zero emissions targets. It will help to accelerate development of integrated commercial ocean energy projects, addressing community and government priorities by providing market access to design cost-effective solutions, ultimately de-risking investment. Initially delivered as a digital platform and knowledge centre, the project will grow to include a physical marketplace in Albany in southwestern Australia, which offers some of the world's highest quality wave energy resources. The marketplace will showcase the on-site generation of electricity through an integrated ocean energy microgrid, utilising a range of wave energy devices to provide perpetual and predictable power, alongside solar and wind devices. Low-power desalination units, modular green hydrogen production, and novel energy storage systems will display the additional benefits of renewables, whilst the Interpretation Centre will offer community engagement opportunities to educate the current and next generation. The marketplace will catalyse commercial projects in off-grid markets, enabling customised hybrid grids to be designed for optimal net zero energy solutions. The Australian Ocean Energy Group believes that seeing leads to understanding, and understanding underpins adoption. We're seeking partners who share our vision to join us in revealing and realising the full potential of integrated ocean energy in the transition to a sustainable future for all. For more information, contact the Australian Ocean Energy Group.
Thank you, Di. That wasn't exactly like watching it in our local Gold Lounge at the cinema, but I'm glad we could actually hear it and see it. So thanks for showing that. It's also just been posted on Australian Ocean Energy Group's website. If anybody wants to have a closer look or share that, you're more than welcome to. Listen, in closing, I'd just like to say that we're eminently grateful to our members and partners who facilitated our growth and seeing this conceptual marketplace plan developed to this phase. And huge thanks to NERA, UWA, and the Wave Energy Research Centre for their direct support and collaboration. And a big shout out to the West Australian Government and the Blue Economy CRC for including us as part of their funding for the recently announced M4 Wave Energy project in Albany. And the construction of the M4 is a project that really will build the cornerstone around which this marketplace commercialization element can be implemented. And in due time, we hope to replicate this in a tidal energy demonstration project somewhere else in Australia. But we do have a long way to go in developing a detailed understanding of the market dynamics, in developing the business model to underpin this marketplace product, and in our ongoing discussions with the end-to-end stakeholders of the CRC and the ultimate beneficiaries of ocean energy systems. So just last slide. Thanks, Leslie. I just want to thank you guys for listening and for your interest in the topic of wave and tidal energy and its role in decarbonizing the blue economy. And thank you also for helping to break the mold for a slow adoption of smart renewable solutions. And if you're keen to be involved, we invite you to join us very much on this journey. So you can make contact with Stephanie or myself directly, and we very much look forward to those conversations. So thanks again.
Thank you very much, Alex. I'm going to pass it over to Stephanie, who would like to have some closing words. And then I will also just close off on where you can find some information about today's webinar. Over to you, Stephanie.
Thank you, Irene. Well, first and foremost, I want to thank all my presenters. They did a fabulous job, and it's so exciting. I hope all of you in the audience really are excited as we are about the progress and the innovations that are taking place. And as you can see, it's no easy feat, and it does take a village to really build a sector and an industry and to help each of the individual companies be successful. So any of you that are interested in being part of this journey, we invite you to join connect with the Blue Economy CRC. You can join AOEG as a member, and you can be involved with individual companies to be part of helping them on their journey as well. So with that, we really bring this to a close. I know we didn't answer all the questions, but I want to assure you we will receive copies of all the questions, and we'll make sure that we respond offline and after this event. So with that, I'll wrap it all up and just say my sincere thanks and turn it back to you. And again, my thanks to Blue Economy CRC. It's been terrific.
Thank you. Thank you very much to the Australian Ocean Energy Group, to all the members that are part of AOEG that presented today here in the CRC's webinar series. Very informative presentations and many great questions that you've had the opportunity to answer, of course, while we haven't had as much time in the Q&A. I thank everyone for attending today's webinar. Just to let you know that the webinar will be made available on the CRC's website. So where you found this event, if you click this event, you'll also see a copy of this presentation basically available for you to download. In terms of the PowerPoint slides for any of the presentations that our presenters are happy to share, we'll also provide links to those on the webinar's events page as well. I look forward to welcoming you to another webinar in the future. The CRC is planning another very exciting wave energy webinar later this year in November. And we have other upcoming webinars coming up in October as well. And I look forward to talking to you all again. Thank you very much.
Thank you all.
Thank you.